Welcome back to the class, guys. So in this class we are going to learn about OSI model. What is OSI? OSI stands for Open Systems Interconnection. OSI model is a reference model that is used to describe how data transfers from one system to another system in a network. As you can see in this slide, we have a Windows machine and a Linux machine, and it could be a Mac machine also. So two machines have two different operating systems, or it could be a mobile at other end also. So two different communicating systems may have two different architectures and can be connected by cables. Say for example, the Windows machine is connected using RJ45 connector, so that NIC is connected via RJ45 Cat5 cable, and the other system may be using a Wi-Fi connection using a Wi-Fi home router. So how a data is sent from Windows machine to a Linux machine or a mobile is described using OSI model. OSI model is a conceptual framework that describes the functions or functionality of telecommunications or computer systems, or simply networking functionality, and the model is in the form of 7 layers stacked on top of each other, and each layer has its own functionality on how the data is handled at each layer before sending from one system, and even these layers functions when the data is received at a receiving system. OSI model was introduced in year 1984 and was introduced by International Organization for Standardization. So this model is often called as ISO OSI, and the 7 layers in OSI model are application layer, presentation layer, session layer, transport layer, network layer, data link layer, and physical layer. And the data is passed through each of these layers even when you are sending or receiving the data. And the data alone does not pass through these layers. Additional information is added to data, often called as headers to the data at different layers. And you have to memorize these 7 layers because interviewer may ask this question, and you can easily remember these 7 layers using a statement that you can see on the screen. Considering from bottom to top, that is from layer 1, physical layer, to application layer, please do not trust salesperson advice. Nice sentence, right? If you take the first letter in each word, you can easily remember the 7 layers. As you can see, please for physical layer, do for data link layer, not for network layer, trust for transport, and so on. There is another statement also: please do not throw sausage pizza away. You can remember either of these statements in order to remember the OSI layers in this OSI model. If you want to remember the layers from the top to bottom, that is from the layer 7 to 1, there is another statement which is: all people seems to need data processing. So you can choose one of the 3 statements in order to learn or memorize the layers of OSI model. As you can see in the screen, sender is sending the data over the network to the receiver or client. So sender side you have these 7 layers: application, presentation to the physical layer. But theoretically, OSI layer is considered from bottom to top, that is physical layer to application layer. People have so much confusion which is a top layer and which is a bottom layer. So now in this screen you can see that sender side, the top layer is application layer, and to the bottom, which is 7th layer, is a physical layer. While at a receiver side or a client side, the top layer is down, it is a physical layer. So when the data is received, it first received at a physical layer, then the data moves up decapsulating and is displayed on the user's interface. In the telecommunications world or networking world, the data does not create itself, or it does not fall from the sky or Mars. Someone has to create the data or produce the data. If you want to send me a chat message, or you want to write me an email, that is actually producing a data, and you need an interface, which is an application that provides you interface so that you can produce the data and send, is associated at application layer, and down through the physical layer it goes via cables, and at the end machine I am going to receive your message or your email over the network, that is internet, using different kinds of media. Media could be wired, cables, satellite, and so on, and finally when it reaches to my laptop via my Wi-Fi router, or if I'm connected via CAT cable, then finally reaching to a Skype interface. Say for example the chat application is Skype, then I can read the chat message that you have sent. So at the sender side, the application layer is a top layer, and at the receiver side, the top layer is a physical layer. As already said, data does not pass through these layers alone. At layers, it adds some headers, and from top layer to the bottom layer, when the headers are adding at each layer, this process is called as encapsulation. And then finally, when the data or message is reached at destination PC or a destination device where it is intended to send, the data passes through physical layer to application layer, and that process is called as decapsulation, because the headers are removed from the top layer, that is physical layer, to the application layer at the receiver side. So this process is called as a decapsulation. So when you are sending and receiving data, each time encapsulation and decapsulation takes place. And the top three layers in OSI model are called as software layers, that is application layer, presentation layer, and session layer. Transport layer is heart of ISO, and the bottom three layers, network, data link, and physical layers, are called hardware layers. And why they are called as software layers, hardware layers, and heart of ISO, you will know when you learn about each of these layers individually. And as you know, OSI layer is stack of 7 layers. Each layer is again a stack of protocols. As you can see in the image, application layer example protocols are DNS, HTTP, SMTP, POP, Telnet, and FTP. For example, if you want to download a file, FTP is the protocol that is used or that works behind the scenes in application layer, as you have an interface to download the file. And similarly, if you want to browse internet, HTTP is the protocol that functions over here. Similarly, in the presentation layer, you have HTML, doc, JPG, MP3, MP4. These are presentation layer protocols. Similarly, session layer, you have TCP, SIP, RTP, RPC, and so on, named pipes. Transport layer, which is actually heart of OSI, TCP, UDP. We are going to learn about TCP, UDP headers, as well as SSL and TLS are the protocol that are there in this transport layer. And in the network layer, the below layers are hardware layers. So in the network layer, you have IP, Internet Protocol, IPsec, Internet Protocol Security, ICMP, IGRP, OSPF, and data link layer, you have Ethernet, 802.11, MAC, LLC, WAN, ATM, frame relay, and so on. And finally, at physical layer, you have RJ232, RJ45, V.34, and 100 base TX, and so on. So let us now learn about each of these layers individually. So let us start with application layer. Application layer is topmost layer to the sender side and is considered as a closest layer to the user either sides. A closest layer means if you are a sender, you are sending or producing data using applications, so the application layer is closest to the sender side, as well as the other side, the receiver side. You are reading the data using some other application, so it is the application layer where message is displaying on your interface so that you can read. So either side, application layer is the closest layer to the user. So application layer uses network applications to interact with the user to produce the data and receive the data. So the function of application layer typically includes verifying the availability of communication partners and resources to support the produced data for the transferring of this data. Application layer also defines the end-to-end protocols such as DNS, FTP, HTTP, and so on. And when I mean network applications, applications are those applications that uses internet for data transfer. For example, your browser is network application like your Firefox or a Chrome, or your chat application like Skype, Messenger, and so on are chat applications. So these are all the applications that uses internet are called network applications. And as you can see, protocols that functions at this layer, that is application layer, are HTTP, HTTPS, FTP, SNMP, DHCP, Telnet, and so on. And just while ago we have taken example of browsers and chat application as a network application. So browsers use HTTP, HTTPS protocols for web surfing. Similarly, you can use FileZilla for file transfers and uses FTP as a protocol. And for sending emails, Outlook is an example as network application and uses SMTP as a protocol. And if you want to remotely communicate with someone or a server, you use a virtual terminal, and telnet is a protocol that is used in the application layer, and so on. So from sender's machine or sender's PC perspective, the application layer data is now sent to presentation layer. The main function of presentation layer is translation, compression, and encryption. Presentation layer deals with syntaxes and semantics information which exchange between two devices. So the protocols that functions here are HTML, doc, JPG, MP3, and so on. So as said, the primary functions of presentation layer are translation. The data from the application layer comes in the form of numbers and characters. So the presentation layer converts these numbers and characters into a machine understandable format. For example, ASCII to EBC DIC code, that is extended binary coded decimal interchange code, and this function is called data translation by presentation layer. And before the data is transmitted to the below layer, this layer functions by reducing the number of characters to fewer characters that represents the original data, and this bit reduction process is called data compression. Data compression is highly useful in video processing because the size of data is reduced and can stream very fast, and this data compression could be lossy or lossless. The next function of presentation layer is encryption. So after compression and before transmitting to the further layer, the data is encrypted to maintain the integrity of data. In case of receiver side, the data is decrypted before sending to the above layer, that is application layer. But since we are taking the example of sender's machine, so data we have received from the application layer, so now presentation layer is translated, then compressed, and now encrypted the data to maintain the integrity of the data before sending it to the below layer, that is session layer. Applying data encryption enhances the security of that data that is transmitted over the network, and it is done using SSL protocol in the presentation layer. So at the sender side, data is encrypted, and at receiver side, data is decrypted. Next, we have session layer. The primary function of session layer is to establish the session, that is connection between two computers or communicating computers, then manage the session and terminate the session after communication between the two devices is complete or over. In order to establish communications between two devices, session layer also performs two other functions, that is authentication and authorization. A machine is authenticated using its authentication credentials. For example, user has to give username and password as an input. If the credentials are correct, the user is authenticated and connection is established. Now this session layer also checks for authorization. As now user or machine is authenticated, to what level user is permitted to access resources on the communicating device. So what is the difference between authentication and authorization is very important question. Interviewer may ask the difference between authentication and authorization. So the primary functions of session layer are establishing, managing and termination of sessions, and checking for authentication and authorization. So above three layers, application layer, presentation layer and session layer, are software layers, and data is produced, presented, and session is established, and now data is ready to send to transport layer. So data at these software layers, that is application layer, presentation layer and session layer, are called PDUs, protocol data units. At application layer, it is called as application layer protocol data unit. At presentation layer, it is called as presentation protocol data unit, and at session layer, it is called as session protocol data unit. And now these protocol data units are ready to forward to transport layer. Next, we have transport layer, which is often called as heart of OSI. And the primary functions of transport layer is segmentation, transportation and flow control, reassembly and error control. The protocols that works over here are TCP and UDP. We are going to learn about TCP and UDP headers in the next class. And the reliability of the data communications is done by these functions, which is segmentation, flow control and error control. As you know that we have received protocol data units from the upper layers, that is application layer, presentation layer and session layer. PDUs are now that is data packets are now segmented into smaller chunks or smaller data units, and they are called as segments. And these segments contains source port and destination port as well as the sequence number along with the data units, portion of original data. I said portion of original data because actual data is segmented into different units as segments, and the port numbers are used to send the data to the correct application, and sequence numbers are used to correctly organize the data to form a complete meaningful data. For example, sequence number 1 is allotted to character or word I, sequence number 2 is allotted to word love, and sequence number 3 is allotted to you, word. So the correct order is 1, 2, 3, that is I love you, so that recipient can understand what I am sending as a message. If the sequence numbers gets messed up like 1, 3, 2, that is I, you love, that doesn't make a sense. So in order to produce correct message for the sender side, the sequence numbers are used. Now the function of flow control in presentation layer. Flow control controls the amount of data that is being transferred on IP network. Say for example, you are downloading a movie from an internet and the server is sending you 100 megabits per second, and your device or your laptop has only capacity to receive 20 megabits per second, then your device will tell the server to slow down the rate of data transfer as it cannot be able to process or download the data at that rate of speed. And the other way, opposite way, if the server is sending data at the rate of 10 Mbps and your machine have a capacity to process the data at 20 megabits per second, it will tell the server to increase the data transmission rate, and this is called as a flow control in presentation layer. The next function of transport layer is reassembly and error control. You know, reassembly is using sequence numbers to reassemble the data units to form a full data that was sent by the sender. And error control is a function that finds lost data transmission or lost data units, and automated repeat requests are sent in order to request to resend the missing units or corrupted data units so that it can form full data again, and a checksum is added to every data segment to find out the corrupted or missing data units. And as we discussed earlier, the transportation layer protocols are TCP and UDP along with SSL and TLS. So what is TCP and what is UDP? TCP stands for Transmission Control Protocol and UDP stands for User Datagram Protocol, and both the protocols are used for transporting the data. But why do you need two protocols for doing the same job? That is the difference between TCP and UDP over here. TCP is Transmission Control Protocol and it is connection oriented protocol, while UDP is connectionless protocol. It means that TCP provides feedback of a data delivery. Yes boss, I have sent the data and the recipient has received it, and I am sure here is the acknowledgement. This is what TCP does, while UDP does not provide the feedback on the data delivery. If I order something from Amazon, the Amazon guy will come to my house and that Amazon guy will give me the order that I have ordered, and he will take my signature as an acknowledgement that I have actually taken the product from the Amazon guy. While in morning hours, the newspaper guy will come to my home, throw the newspaper into my balcony. Sometimes it falls into the balcony correct, and sometimes it falls into my neighbor house, and that day I miss the newspaper. So that is user datagram protocol is compared to newspaper guy, and while the Amazon guy can be compared to the TCP protocol. That is, TCP protocol provides the feedback while the UDP does not. Hence UDP protocol is faster than TCP because it does not carry extra data of acknowledgement section. It means that there is no guarantee of data delivery if UDP protocol is used for transportation of data. But do you think the UDP protocol is used for transportation? Yes, why not? As you can see on the screen, UDP is used for video streaming, games, VoIP, DNS and so on. TCP guarantees the delivery. If any data is lost during the transmission, As said, automated repeat requests are sent to retransmit the lost data. So the data is guaranteed in data transmission and full data is reached to the recipient. And the examples are your World Wide Web, FTP, email, and so on. So now the segments of transportation layer are sent to network layer. In the software layers, the data were called as PDUs, protocol data units. In the transportation layer, you have segmented the data and added source ports and destination ports to all the segments. And now these segments are passed on to network layer. As you can see on the screen, at network layer, when the headers of network layers are added, it is called as a packet. And when data link layer adds its own headers, it is called as a frames. And down below you have bits, zeros and ones. So the next layer is network layer and it has received segments from transportation layer. As you can see in the screen, this red guy is sending data to the blue guy across the network. So the function of network layer is to facilitate data transmission across the networks. And this is done by logical addressing, routing and path determination. So you can say the functions of network layer is logical addressing, routing and path determination. I said network layer is responsible for sending data across networks. So can you guess what devices reside on this network layer? You have already read this in networking device. You can pause the video and try to guess what devices does work over here. Yes, routers functions at network layer because router connects two different networks. It does this function by routing the traffics to and from different networks by checking its routing table for destination network addresses. So in network layer, IP addresses, that is sender's IP address and destination IP addresses are added to segments to form a data packet. And this function is called as a logical addressing. And IP addresses are added to segments along with subnet mask so that routers can identify the network portion of an IP address in order to find out the destination networks. And once data reaches the destination network, now it should reach to the final or intended host. So the host portion of IP address which was mentioned in this network layer as a header to the segment, making it as a packet. So making the data reach to the final destination or final host is routing function of a network layer. And now path determination function of a network layer. Internet is net of networks. It is a web of networks. So once your device is part of a network and if you want to send any message to other device somewhere on the network, there are so many paths or routes available. For example, if I want to reach Washington from Hyderabad, India, I can take a flight from Hyderabad, New Delhi, Afghanistan, then Germany, then I can go to United States. Or else I can take a flight from Hyderabad to Madagascar, then to South Africa, and then to Brazil in South America, and then to Washington in United States. So depending upon my budget, time and convenience, I can take any route I want. So parameters are my financial status, convenience and time factors. So these are all the parameters that affect the route that I can take. Similarly on internet, if a data has to reach from device A to device B, there are so many routes available and it all depends upon the routing protocols. As you can see in the screen over here, there are two computers, black and red, and there are so many paths that you can send a message. If you carefully see and do some permutation combinations, you can take out some n number of paths to send data from blue computer to a black computer. And this depends upon protocols like OSPF, Open Shortest Path First, BGP, Border Gateway Protocol, ISIS, Intermediate Systems, and so on. And this is called as a path determination function of a network layer. Now the packets of network layer is sent to the down layer, that is data link layer. So now remember or realize that the data has source port, destination port, sequence number, source IP, destination IP and checksum. And this is called packet. Packet is sent to data link layer. You know there are two types of addresses, logical address and physical address. Logical address is IP address which were added to segments to form a packets in the network layer. So now the packets are in data link layers. Data link layer add MAC addresses, source MAC address and destination MAC address to the packets to form frames. And you know what is a MAC address? It is 12-digit alphanumeric number that is added to your NIC cards, which is a physical address. And layer 2 switches functions in data link layer. And switches or NIC cards of your end device have ports, Ethernet ports, that provides means to connect cables in order to transfer data from one computer to another computer using the media, and the media could be copper wires, optical fibers, or your Wi-Fi or radio signals. The function of data link layer is to access data from the upper layers by method called framing, and also controls how data is placed on the media or received from the media, and it is done by media access control. And the final layer of OSI model is physical layer in sender's perspective. And till now data units were segmented, and then IP addresses were added to form packets, then MAC addresses were added to form frames, and these frames are sequence of binary numbers, the bits, and physical layer converts these binary numbers into signals and places on transmission media. And these signals could be or three types: electrical signals if you are using copper cables, and light signals if you are using optical fibers, and could be radio signals in case of wireless transmission. Data once produced at application layer and processing through each of the layer, adding headers at each layer, is called as encapsulation. And once the data is reached to the destination computer or a device, the whole process of encapsulation reverses. It means that data once reached to physical layer at destination computer or destination device, then signal is converted back to bits or sequence of binary numbers, and then MAC addresses are removed at data link layer, IP addresses are removed at network layer, then source port and destination port number are removed at transport layer, and so on, and the data is sent to the upper layers, and at application layer the data is displayed at user's interface. And this process is called as a decapsulation at receiver's end. So these are the 7 layers of OSI models stacked on top of each other, which describes how data is transferred between two devices. And OSI model is just a reference model, it is not an original model. The original model is TCP IP model that is you are seeing on the screen. There is no much difference between OSI model and a TCP IP model. The top layers, that is application layer, presentation layer and session layer, is considered as an application layer in TCP IP model. And the bottom layers, data link layer and physical layer, is considered as a link layer, that is the original TCP IP model. Now the updated TCP IP model has been again updated by modifying the link layer to physical layer and data link layer separately. But the encapsulation of data from application layer to physical layer is same in all the models. So in the next class we are going to see TCP three-way handshake. Thank you for watching the video, and do subscribe to the YouTube channel INSECTECHS.